Okay, the next thing we need to look at is what's called the down cell, and there's some principles that go along with that that you need to be aware of as well. So in your notes, we're looking at this one right here. And the first thing I want to point out is if you look at this diagram, it's this word right here. This is molten NaCl. This is not aqueous sodium chloride. This is salt that you heated up until it melted. So this is like salt lava, basically. So one important thing to do is whenever you're dealing with ionic compounds that are molten, they're still going to dissociate. So when you have NaCl go into here and we heat it up, it's still going to break up into Na positive and Cl negative, but not aqueous. Like it does dissociate into ions, but not aqueous. That's the key. So we do have in here Na positive and Cl negative, and that's all. Nothing else. No water, nothing. So if you look at the reaction here, that's your two reactions. So Na positive ends up being your strongest OA, and the Cl negative is your strongest Ra, and then you could figure out the reactions. You could figure out the voltage that would be required, any of that. So there's really nothing super new about this one other than the concept of molten ionic compounds still dissociating into their ionic parts, but they would basically just be in a liquid state, not in an aqueous state. So just be aware of that. Another thing to think of on this one is if you had Na positive, which is way down here, and you've got Cl negative, which is way up here, if water were present, it would be stronger than both of these. So you would expect the water and the water to react. That's not a huge deal, but really the biggest thing for you to remember is just that idea that it's aqueous ions, and that's it. Okay. All right, the next one is, let's drop down here in the notes. We can fit both of these into one video. Is the electrolysis of brine, which is just salt water. So in the electrolysis of salt water, you have water and sodium chloride ions. Now there's probably other things in, like in, let's say, ocean water. There's other compounds, and unless the question specifically mentions them, I wouldn't worry about them. But if they do say anything about ocean water, at the very least you should consider water, sodium, and chloride. Now, we're not going to do the full reaction here, but I just want to show you this. Kind of like I mentioned on the last one, Na positive is a very weak oxidizing agent, and Cl negative is a very weak reducing agent if you're looking on your table. Water essentially should be the only thing that reacts here. If we were to predict this reaction, we would say that water would be the strongest OA and water would be the strongest Ra, and that's what we would assume we would see. The reason you need to know this one is that this is an example where the predicted reaction does not occur. So we would expect water and water for whatever reason. In fact, let's draw that in here, and we'll just say this is the predicted, right, my strongest OA and strongest Ra. And then we'll draw another line and show this is the actual. So for whatever reason, in reality, the water as an OA reacts with the chloride ions as an Ra. And that's essentially all you need to know. You need to know this specific example, and I would write somewhere in your notes that this is an example of where the predicted reaction does not occur. And that's it. So the two examples from this video, make sure you know if it's a molten ionic compound, you're going to still have ions, but no water present, not aqueous. But in the case of this one specifically, if you did have electrolysis of brine, then we get, it's an example of when the predicted reaction doesn't occur. Okay? And I think that's it. Other than that, you've got the homework questions to work your way through. So 1, 2, 3, 4 pages it looks like. And if you have any questions or have any problems, let me know. And see you later.